So in this question, we're told that the motorcyclist tries to undergo a loop-the-loop. So let's just draw a diagram. Here's the loop-the-loop. Now at the top, his speed, v, is equal to 6.0 I. It's negative I, so it's going in the negative direction, meters per second. And that's when he is up here. And part one of the question asks us, well, does he make it round the loop? So in order to make it round the loop, we need to satisfy the condition that the velocity has to be greater than the square root of gr. We're told that the radius of this loop is equal to 2.7 meters, and we'll need the mass later, so let's write it down. The mass is equal to 150 kilograms. That's for the motorcyclist plus the motorcycle. Okay, so let's calculate what velocity is required in order to just make it round the loop. So v is equal to the square root of gr, so 9.8 times 2.7. Solving this on the calculator, we get 5.14 meters per second. So as 6 meters per second is greater than 5.14 meters per second, the motorcyclist does make it all the way around the loop. Now, in part 2, we're asked what's the normal force of the track on the motorcyclist and the motorcycle at the top of the loop. Okay, so in order to do that, let's draw on our different forces. So we've got our weight force, which is acting down, that's mg, I've done that blue. We've got our normal reaction force, I've drawn that green, also acting down, and that's the normal force, so it's perpendicular to the surface. And then we've also got our resultant force, which is our centripetal force, which is acting downwards towards the center, because it's centripetal motion and that always acts towards the center, and that's given by mv squared on r. So Newton's second law tells us that the sum of the forces is equal to ma, and for the centripetal force, this ma is equal to mv squared on r. So the sum of the forces have to be equal to this, so the two forces acting on him are n plus mg. And what we're trying to do is find this normal force here. So all these forces are directed down. So let's rearrange it, and we've got normal is equal to mv squared on r minus mg down. So we can pull m out. So we've got mv squared on r minus g. So now we can substitute in. We've got 150 times v squared, which he's going at 6 meters per second, so that's 6 squared over 2.7 minus g, which is 9.8, and solving this on the calculator we get 530 newtons. Now we should give this in unit vector notation, so it's in the downwards direction. If we've called this direction I, then upwards is j, and since it's going down it'll be minus j. So the normal force is n is equal to minus 530 j newtons.